welcome back, everyone. Hello. All right, so this is your Tuesday lecture. Thank you so much, those of you who are staying after school to be my live studio audience. Shout out to you guys.
Yeah.
Woo! All right, we're going to have some fun today, get a lot of stuff done. We're working on slopes of lines today. Update your table of contents, please. This is lesson code C3L3, so in your textbook, chapter 3, lesson 3. Slopes of lines. Don't forget to leave the next page from the notes that we just finished taking on Thursday blank for your KWL. Here's where we're going to begin today's notes. As always, the title and lesson code listed under the La Feria logo, as well as the objectives. Go ahead and pause the video now and get those written down. All right, I just want to recall, and I'm going to put a star and then a recall, not because this is something that we've done in our class, but this is something that you likely have seen in Algebra 1, and that is the slope of a line. Hook me up. What do you recall from slope of a line?
Rise over run.
Yeah. It's rise over run.
Y equals x plus y intercept.
All right. Hold on to that. We're not quite ready for that one yet. But rise over one, what this is talking about is if we're on some sort of coordinate XY plane, and I have some lines sitting here, then however far I have to go up before I get to the same level as my line is my run. This is my run. And however far I have to go to the side before I get back onto the line, that's my run. And it's a fraction and a ratio. We're going to go ahead and work with that a little bit today. And here's the general formula, because I'm not going to give you graphs. I'm evil. I'm just going to give you numbers. So our slope formula from Algebra 1 looks like this. Okay, I know they're triangles. But in math, the symbol of little triangle, when we have it in a formula, means the change in. So I can rewrite this formula as the change in y values, y2 minus y1, over the change in my x values, x2 minus x1. Let's go ahead and do an example to remind you guys how to calculate the slope of numbers. Or lines, rather. Find the slope of the line containing the points 1, 2, 3, 4. All right, we're going to start with our slope formula. We're going to say that the slope, we're going to use the variable m to represent slope. And it is going to be the change in y, y2 minus y1, divided by the change in x, x2 minus x1. Substituting what I know. Oh, I need to decide which one is which. Which point is x1, y1?
X1 is 1.
All right, so he wants 1 to be x1, which means 2 is y1, which forces the other point to be x2, y2. All right, now I can do my y's. And now I can substitute my x's. And when I do my subtraction, I'm going to end up with 4 minus 2 is 2. 3 minus 1 is 2. And so my slope is 1. All right. Nothing too terribly complicated yet. Let's look at the slope-intercept form of a line. The slope-intercept form of a linear equation is like a cookie cutter. It's a template to which your formula, your equation should follow in order for it to be considered slope-intercept. And here's that template.
Mx plus b.
Y equals mx plus b. Yes, and it sounds familiar to some, and that's good. This m right here is the same m from the previous example. That is your slope value. This b over here is playing the role, is playing the role of our y-intercept. That y-intercept happens anywhere the x value is 0. Okay? You're going to be asked to find the slope of the line with this following equation. Y equals 3x minus 7. Looking at our cookie cutter, I'm going to write it down right below right here. Our cookie cutter says since we want to find the slope, this is in slope-intercept because it exactly matches our cookie cutter template. And so this is the value of the slope. That's it. It's just that easy. So far, so good? All right. Remember, it does feel like I'm going to be going quickly because, because this is pre-recorded and you can pause me whenever you want. Yes, sir?
Are you going back with algebra or what? Or is this going to go with geometry?
Yep, we're about to go turn it into geometry right now. I want to look in particular now at the slope of parallel lines. And so the first thing I want to do is take a moment to talk about what parallel lines mean. Have you encountered that word before, parallel?
Mm-hmm. Yes, ma'am.
What does that word mean?
But two
Two
lines don't touch.
lines are
Two lines
they
that
never
don't touch.
touch.
Two lines that do not touch.
But are equally
Lines that do not intersect.
That do not meet.
But I want to add one little thing to this, one little bit of detail, and that is that I'm going to force them to be on the same plane. Okay? So we're going to shortcut this definition and say that parallel lines are non-intersecting coplanar lines. Okay? And the important thing to remember about them is that their slopes are equal. The example would be, are the two lines parallel? Here's one line. Here's the other. The slopes need to be equal. Are these in slope-intercept form?
Yes.
Yes, because they look like y equals mx plus b. This is the spot where the m is, which represents our slope. And so for this line, the slope is 3. And for this line, the slope is 3. Since my slopes are equal, the answer is yes, they are parallel. Because our slopes are equal. All right, I'm going to change the page. Live studio audience, I know this might be going fast for you. Don't forget, this is pre-recorded, so you're going to be able to pause it. So I'm going to go a little faster than what I would normally do in class.
Take your time, miss.
Take your time.
Have all the time in the world.
All right, I'm on the next page. I want to talk a little bit about slope of perpendicular lines. And I'm moving into this one next because this one is kind of the weirder one.
Is that the one where the lines go like a plus sign?
Yeah, they kind of make that plus sign, yeah. So just a reminder on what perpendicular is. And I think we talked about this before, didn't we? Yes, with perpendicular bisector.
Mm-hmm.
Oh, yes.
Yes. So this is a recall moment right here. Back to our perpendicular bisector. What did perpendicular mean?
Where
When
two
the
lines
two
make a
lines
plus.
and they are at a 90-degree angle.
Yeah, two lines that intersect at a 90-degree angle. Two lines intersect at a 90-degree angle. But when we're on that XY coordinate plane, we can say one more thing. Not only are they going to intersect at a 90-degree angle, but they are also going to have slopes which are negative reciprocals. Do you know what the word negative means?
Yes.
I'm spelling this wrong, I think.
Yeah.
There we go. Reciprocals.
Remember this first master.
What does negative mean?
Number that's behind zero.
Less than zero or
Less than
has
zero.
some sort of negative sign attached to it. And reciprocal?
I forgot that one.
When the fractions flip.
Yeah, when we have a fraction that's like this and we flip it so that it looks like this.
Oh, you see it? Oh.
So if we take our slope m, to get the negative reciprocal of that, you're going to add a negative to it, and then you're going to take the reciprocal of your slope m so it looks like that. There's a check. Okay? If you don't know if the two numbers you're looking at are negative reciprocals of each other, there's some sort of decimals or the fractions don't seem to line up right, we have a really easy check. Okay? And we're going to do that check as the example. Are these lines perpendicular? Uh, 0.3x minus 1 and y equals 4x plus 12. I have no idea. I just made up numbers. I have a feeling it's not. But I don't really know.
Can I have a calculator?
Yeah, you can grab a calculator. We're going to need one. All right. Oh, wait. I think wait. Let's change this 3 to a 2, 5. Sorry, I just started doing some multiplication in my head, and I think this is going to work out. And then put a negative in front of it. So make the first slope a negative 0.25 and the other slope of 4. Okay. So our test is to take the two different slopes and multiply them together. And then we want to check to see if the answer we get is a negative 1. If it is, then they're perpendicular. If it's not, then they're not perpendicular. Okay, so slope 1 is 0.25 and slope 2 is a positive 4. So grab a calculator and type in this and tell me what you get.
Is that times 4?
Yeah, this is a multiplication right here. So negative 0.25 times 4
Negative 1.
equals negative 1. So yes, these lines are perpendicular. Because they passed our test. Good job, slopes, you're not failing. Let's put all of this mess together into one big example. Given the following information, tell if the lines are parallel, perpendicular, or neither. Point A. Point B. Oh, I need to name the lines. Okay, I will in a second. I don't know. 2 and negative 7. Oh, sorry. All right, I have no idea. I should have asked you guys for numbers, but I was going ham. I have no idea. But the lines that we're interested in are going to be line AB to line CD, and then line AC to line BD. Now we can do this with all the other different combinations of lines, but I want to run these two first. So this is going to be one set of answers, this is going to be another set of answers. Okay? And we're going to put our little symbol parallel or perpendicular or neither, I guess. All right. I'm not given any slopes, but I'm given points, aren't I?
Yes.
Which means the first thing that we should do is calculate the slope of each line. So the slope of line AB, which is the first one that I want to calculate, and I'm going to zoom in really tight here on my work, is going to be given by the formula change in y over change in x. But I'm going to use that for AB. Now I'm going to cheat here a little bit, and I'm going to call the top one x2, y2, and the bottom one x1, y1, just so that I can, as I'm writing left to right, I can just read top to bottom. So y2 is 3, y1 is 4, x2 is negative 2, x1 is positive 6. So the top is a -1, the bottom's a -8, and there's my slope for line AB. Repeat for line CD. Pause the video now and do it. And then unpause it so that you can see what I did. All right, so here we go. Welcome back after you have paused it. We're going to go ahead and put in the slope formula. And now we're going to use the same trick we used on AB here, so that I'm going to write right to left, but I'm going to read top to bottom. So y2 -1, y1 -7, x2 -1, x1 is a 2. I have a double negative here, and I can think of that as a positive. So -1 plus 7 is 6, and -1 minus 2 is -3. So my slope is a -2. Whoops, that went off the screen, sorry. Okay, just giving myself a little bit of a workspace. All right, so the slope of AB is a positive 1/8, and the slope of CD is a -2. The first question to ask yourself is, are the lines parallel? Are the slopes the same?
No.
No, so there's no way they could be parallel. Okay, so the first thing that I know is that they're not parallel. And the symbol we're going to use is we're going to put two lines like they're parallel, and then we're going to scratch through it this way. Not parallel. Are they perpendicular?
Yes.
They are?
Yes.
Okay. She says no, he says yes. So go to your calculator, and we're going to run our perpendicular check. Take 1/8, multiply it by -2, and what you want to come out is -1. Do you?
No.
No. You get -0.5.
-15 over 8. Oh, -1.875 in decimal form.
That seems weird to me.
Yeah,
Double
what
check,
about-
put your 1/8 in parentheses.
Hold on.
Okay? When you're doing it on the calculator, put your 1/8 in parentheses, because that number seems weird. My
Oh,
brain
yeah.
is saying -0.5.
-104.
Is that -1?
No.
No. So there's no way these two lines could be perpendicular. And so the perpendicular. And so the symbol we're going to use for not perpendicular is we're going to do the upside down T for perpendicular, and then scratch a line through them. So whatever these two lines are, they're not parallel and they're not perpendicular. Do you feel comfortable deciding if they're parallel or perpendicular based off the equation?
Yes.
Yes? Okay. I had one shake ahead, so I'm just going to zoom back up here just to review it. When you're given the equations of lines, if they're in that slope-intercept form, y equals mx plus b, you're going to look at the coefficient of x, that number that is in front of the x. If those numbers are the same, they're parallel. If they're different, you have to run it through this check here, the perpendicular check. You multiply them together and hope for a -1. If you get that -1, they're perpendicular. If you don't, they're not. Okay?
Is it always going to be?
It must always be -1 to be perpendicular. If, like in our bottom example down here, you get anything else, they're not perpendicular. Okay? So remember that negation thing?
Mm-hmm.
They're not parallel, they're not perpendicular. I don't know what they are, I don't know what angle these things intersect at. I don't know what the picture looks like because I haven't drawn one, but I can honestly tell you that they're not going to be parallel, so they're intersecting. But they're not perpendicular, so they're not intersecting at a 90-degree angle. How they're intersecting, I have no idea. But they are, just not at 90. Okay? All right. That's it. That's all I had. Thank you very much. Oh, I even get applause on this one, too.